writing clean SQL code. Open any SQL book, view lectures on YouTube for SQL or in other resources teaching you how to write SQL. Search for tips over the web on how to write SQL. Read blog posts on how to write SQL. What you'll find in 99.999% of the times is that they will teach you how to write complex SQL, sophisticated SQL, smart SQL, how to mess with joins, what's the differences between the different joins, what are window-based functions, how do you find the first item inside a table. What you will not find, however, is how to write clean SQL, one which is maintainable. Therefore, I'm coming up with this episode, which is my learnings on how to write good, clean SQL. The thing is this. We have the software engineering industry where we have already learned how to write clean code. We know the importance of variable namings. We actually had like tens of years of debates on variable names. We had many debates on whether functions should be small or big, one page, do a single thing. And we, in general, know how to structure very well standard code, such as Java code. We have dependency injections. We have sophisticated tools for refactoring code. And in general, the contract for writing code is, though not fully solvable, but it was pretty much solved. I mean, we know what are the basics and we have a common base of an agreement of what is a clean code. However, when it comes to SQL, the focus is on how to write smart SQL. And what this ends up with is large SQL bulks, which only the maintainer can fully understand, with many magic numbers, with many constants, and basically without prior knowledge or documentation or a very deep understanding of complex SQL, you will find that as someone who is looking at this SQL, it's going to be very problematic to maintain, read, and take over this SQL. So, we have two methods. We have one clean method for writing standard code, and we have another messy method for writing SQL. So, just don't get me wrong. I love SQL. It's an amazing, amazing language. It's very declarative. It's highly sophisticated. It's a mind-blowing language. The issue is that we are focused on the smartness of it, and we should add the focus on the cleanness of it. So I think we can say that while we solved this problem in standard coding, we can take maybe these lessons from standard, let's say, Java coding into SQL. So let's ask ourselves, how do we write clean code in a standard language, such as Java? What we do in Java in order to write clean code is to separate, to have pieces of code where you can understand them. You give variables meaningful names. You give functions meaningful names. You have input into a function. Then you can see clearly the output of it with a type. We have the SRP, single responsibility principle, which means we focus on a specific thing and solve it. We know that if you look at a function and you see a serial set of commands which make sense, you look at the first variable, it's getting something from another function. You look at the second variable, it's manipulating it. You look at the third variable and the third command, it's doing some additional manipulation. And then you look at the fourth variable, it's like the final summary, and then you return this value. You look at the function, it fully makes sense. You know what's the input, you know what's the output, and you know how you got to it. So let's take this process into SQL. Let's see where we don't want to get to with SQL. We don't want to get into large queries with many constants, magic numbers and magic strings, which you have no idea where they came from, with many joins, with combination of window functions, and you involve multiple domains. You take multiple tables, you join them, and you come up to the result with a single large or few large, very large SQLs. This is going to be a mess, impossible to maintain. So let's first take the concept of a variable. Concept of a variable means we do a call and we get a return value. How can we do this with SQL? We can accomplish this with a temp table. So instead of calling a function which returns a value, we're going to create a temp table or a permanent table. The table name is going to be our variable name. So give it a meaningful name. You do the select on this table. You filter out the items, let's say by dates. You take the result and you give it a meaningful variable name. This is the new temp table variable name. Okay? Then you need to take some other data. So again, we're going to create a temp table, do a small SQL. If we have a window function for this temp table, we use the window function. If we have a minor join, we do this minor join that we must do. If we need to filter by something that we must filter. Okay, because if you don't really have to filter by something, in these temp tables, I would prefer not to filter by it. Because in this way, this would assist debuggability. If you're doing all the filters in a single query, and then you find that something is strange, how would you possibly know at which point did the filter go wrong? So it's better not to filter, to create a temp table, which would contain even more rows than needed. Of course, as much as you can, right? And then for each such temp table, you give a meaningful variable name, and you now have, lo and behold, a set of temp tables, each of which is like a variable in Java code, which contains some data. And then we want to do the final aggregation and to return the value from the function to the user. So then we take another SQL and another temp table with the whole purpose of doing the joins in between the above temp tables that we created. So we take the last table, we give it a meaningful table name, which is like a meaningful variable name or a meaningful function. And this select would look like almost no logic. It's only going to do the inner joins and the joins in between the above variables. It's like we're taking the above variables and combining them. What did we achieve with this? We achieved an SQL where someone can look at it. He would see a list of meaningful table names, each of which is like a meaningful variable name. He would see small SQLs, not huge, large ones. Each small SQL resolved with a very clear table name. He would be able to refactor this code because he would be able to focus on a single table name and change it instead of looking at the multiple pages, single one bulk of a SQL. Actually, we call it HellSQL. And there is just no possibility to refactor or to clean it because so if you have these smaller SQLs, you can take one of them, you can test it, you can see what's the result is. You can maybe write a task in SQL that would result one if you pass and result into a new table name, which you could call test 0 if the test fails. So we are even getting closer to unit test with SQL. We are going to have good names for our table names. So you could just look at the names of the tables without looking at the SQL. This is also important in standard programming languages where you look at the variables, you look at the function names, and without looking internally, you already understand what is going on. Because now we have both the big picture and the inner detailed picture. And both are important in order to understand the topic. Just as if you want to understand any topic, you need to move back and forth in between the larger picture and the smaller picture. And we achieved some other concepts, but they are just named, like SRP, Single Responsibility Principle, where each table is responsible for it. We got short, understandable queries. With this, of course, when I'm saying timetables, it doesn't mean that it has to be a timetable. There are different ways to achieve this. You have the select into, where you do a select and you say, I want the result to get into some table. You can use the with. If you're using Postgres SQL, then you have the with keyword. Okay. And you use these smaller building blocks. So I think with that, we can conclude. It's taking the motifs that we have in standard coding language, and the next time you're going to write some SQL, split it into very small SQLs. Don't do all the filtering in each such smaller SQL. Join them at the end, give meaningful names into each one so that someone from the outside could look at the meaningful names and understand what each step table is doing. And then you could refactor, clean it, and test it. So I hope we covered with this episode this not so covered aspect of SQL, because as we said, all the SQL books, the lectures, the tips, the blogs, they all focused on how to write smart SQL, but how to write clean SQL. So this is what I try to describe in this episode. And as always, if you have any comments on this, any ideas on this, then please leave a comment as a manner of review, and I will read it. Thank you for listening, and see you next time.